Good afternoon, student. Good afternoon, good afternoon. Can you see the screen? Can you hear me? Anybody? Miss Scott, can you see the screen? Can you hear me?
Yes, sir.
Yes, sir.
So I didn't understand. I have to call it. All right. All right, so we're gonna work through this paper today. So a lot of persons absent. Don't know what's happening. A lot of persons missing today, but we have to move on. The end of the day, session is being recorded, so those who are not here can join. So I'm gonna do some of the questions on this paper today. This is June 2022, June 2022. And again, more than likely would have done these questions before. All right. While we were doing topics one at a time. That's how it is. That's how I master these things by repeating doing questions multiple times. So get comfortable with all of them. All right, let's go. First question is to use a calculator or otherwise find the exact value of this thing. So we're just going to put that calculator, what it is. All right, put it in this division sign right here. So be careful. So it's 7/8 plus that's 1/6 and then divided by 2/9. And the exact value for that is this 13/8, or we could use this one. But this exact, 1.625. All right, because they give us as a fraction, giving them back as a fraction. So 13/8. We use a calculator. That is it. Yeah, this one, we're going to use a calculator and this one again. And it's going to be 8/0.4 cubed. And that is 125. 125. That's amazing. 3 marks. 3 marks in this one. 2 decimal places. Again, I want to put this in a calculator. I'm still battling with a cold, so you have to bear with me. I have a cough. It's really, really bad. Minus 2.5 is for power. That was a fraction 3/2. 3/2 is 1.5. I'm going to put 1.5 at the power. But I'm going to put a fraction up on the power still again. I'll put 3/2. And they want that answer to 2 decimal places. So if I write it out first, it'd be something like 1.22402. Right, something like that. But I only want it to 2 decimal places. So these are the 2 decimal places. So use your mic, please, using this for to correct this 2 decimal places, so you do not change it. It remains 122. So to 2 decimal places, it is 1.22. So 2 decimal places. That's it. Nice and easy. All right, let's check sure that what you put in the calculator is exactly what you have there. All right, that looks good. Let's continue. Here we have from consumer meeting. All right, it says, children go to a rodeo camp during the Easter holiday. Miss Rekba buys bananas and oranges for the children at the camp. Bananas cost $3.85 per kilogram. Miss Rekba buys 25 kilograms of bananas and receive a discount of 12%. How much money does she spend for the bananas? So if she gets a discount of 12%, it means that she's spending 88%. That's 100 minus 12. she's spending 88% of the amount that she's supposed to pay. All right, that's the first thing. So she pays 88%. She pays 100 minus 12% of the amount she's supposed to pay. All right, which is 88%. i.e., she pays 88% of the amount that she's supposed to pay. And the amount she's supposed to pay is this amount per kilogram times the 25 kilograms. That's the amount that she originally has to pay, but she's paying 88% of that. All right. And so she spends 88 over 100 times the amount that she was originally supposed to pay. 25 kilograms times the amount per kilogram, which is 385, 3.35. And shift this up a bit and make it smaller. We can keep it there. So the amount she pays is equal to, we're going to just do this calculation. She pays 88%. 88% is the amount 0.88. So 0.88 times 25 kilograms times 3.85 per kilogram. So she's paying $84.70. Now, what some persons might do, they will calculate the amount she's supposed to pay, calculate the 12%, and then subtract that 12% from the total amount that she's supposed to pay. But we need to learn to do the mathematics quick and fast like this. To realize that if you're paying 12% less, that's what a discount is. 12% less. Discount is the amount less than the original that she's paying. So she's actually paying 88% of what it was supposed to be. Actually, got a discount of 12%. All right. But understand that? But go to that? But okay with that?
Yes,
Yes,
sir.
sir.
All right. You're pretty. Mute the mic, please. Pretty. Mute the mic. Miss Brekba spends $165.30 inclusive of a 15% tax on oranges. Calculate the original price of the oranges. All right. So if she pays 15% tax, it means that she's paying 115% of the cost price. So this figure is actually 115% of the cost price, because this 15% is 15% more than the cost price. All right, the original price. So let's look at it this way. 115% times the original price, let's just write price, is equal to this amount that she paid, which is 165.31. And you're trying to find the price. So one have to divide by the 115%. Simple as that. Not going to complicate it. If you're paying 15% more, it means that you're paying 115%. So the amount that she pays, which is this, is 115% of the price. Right? So the price becomes this amount of money, 165.31 divided by 115%. 115% is 1.15 divided by 100. And then you work this out and it tells you the answer. Nice and easy. Let's shift this over a bit. All right, so we can put that in the calculator. So it's 165.31. And you're dividing that by 115%. You can actually put 115% in the calculator with the percent like this. I'll get the answer. 143.75. You wrote that for the nearest two decimal places, because money is always written 2 decimal places. So she's paying 1 for the dollar sign. The original price was 143.75. 5 approximately. But okay with that? But good? If we do it a roundabout way, this is the easiest way to do it, believe me. Simplified calculation is only 2 marks, and with a whole heap of space to the work. Learn that if you add 15%, the new figure is 115%. If you take off 15%, the new figure is 85% of the original figure. But good? But good at that? But okay? And if you want, if you're not sure, you could add you can add 50% to this and see if you get back this figure of 165, which you would. If you find 50% of this and then add it, you're going to get back this figure. If you want to do that test, then go ahead. All right, I'm not going to be here doing a monologue now. People have to interact and answer questions. So if I ask if you're okay, but you're good, I'm not moving until I hear a response. It's still a class, if you're not in a classroom. All right, mathematics is not a watching subject. Right, Mr. Mills?
Yes, sir.
So you're good?
Yes,
Understand?
sir.
This one says, the ratio of the number of bananas to the number of oranges is 2 to 3. Furthermore, there are 24 more oranges than bananas. Calculate the number of bananas is bought. Right? So this question gives us the ratio 2 to 3. It also gives us an indication of the difference, 24, in actual terms. Remember, this ratio is just a broken down comparison of the actual numbers. And to get the actual numbers, you can always build back up to the original numbers. But we want to extend the ratio to show the difference because they are giving us information about the difference that we can use. All right, let's look at it this way. So I would say, all right, it is what bananas to oranges, right? It's 2 to 3. So I would say B to O. I'm going to extend the ratio to show the difference. All right, let's put it in purple. Extend the ratio to show how much more oranges are than banana, which is 1. Right? So I'm going to put in the difference right here. The difference. And the figure that they gave us was, sorry, 2 to 3. And the difference between 2 and 3 is 1. 1. But the actual difference is 24. So if I want a line to show the actual, I need to adjust this ratio for the difference to show the real actual, which is 24. To get the 1 to become 24, I need to multiply by 24. Easy like that. Multiply by 24. So I'm multiplying everything by 24. When I do that, this becomes 24 that we know that it is. This 3 sorry, becomes what? 72. And 3 times 24 is 72. Let's put what the blue is 72. And the number of bananas is now 48. And then you can answer anything. If you want the total number of fruits, it will be that. If you want the number of bananas is that. If you want the number of oranges is that. What did they ask us for? The number of bananas, which is this. Right? So from that number, we can just write 40 bananas. 48 bananas. That is it? Yeah, 48 bananas. But okay with that?
Yes, sir.
Yes, sir.
Yeah. All right, moving to the next question, number 2. Number 2 wants us to factorize this thing. All right. Again, we have to learn to look at these, factorize it in one step. We have to practice it, especially when in particular one of the n values is a prime, or 5 is a prime number. So the factors of this 5x squared can only be 5x and x So you actually start the process already. And then now you can test factors of the 4 that would add to give it a middle term. Let's do it a short, but you have to practice it. You have to practice it, guys. All right. So I'm going to start the factorization. It's almost like you're doing a trial and error method. All right. Almost like a trial and error, but you don't have much things to try. That's the beauty about it. So, because the only factors are 5x squared or 5x and x, I can put those in first. Now, what it is now, I want factors of 4 to go here and there. And it has to be such that the far product and the near product add 9x. So I always add, I want them to add because this is a positive. When that's a positive, it is the sum of the far product and the near product gives you the middle term. All right. So we can literally just try factors. But all the factors of 4 to try are 1 and 4 and 2 and 2. That's the only factors to try. So let's say I try 2 and 2. Then my far product would be 10x and my near product would be 12x, would be 2x. And they add to 12x. But my middle term is negative 9x. So I know it can't be 2 and 2. All right, I'm doing it wrong first. All right, so it can't be 2 and 2. So I say, okay, let me put 4 here. Let me put 4 here and 1 here. But those are the other two factors of 4. So I'm putting them wrong first. After a while, you'll be able to just look and know. Here, the far product is 20x and the near product is 1x. These add to 21x. But my middle term is 9x. So it means then that the 1 and the 4 are not placed the right way. I need to reverse them. So I have to put the 4 here and the 1 here. And then the far product now is 5x. The near product is 4x. And these add to 9x. All right, so you have to do the first part, which is to place the values where they're supposed to be. Now, when this end value is positive, it means that the two signs in the bracket are the same. And this tells you what they are both negative. All right, so the two signs in the bracket are negative, and that is the factors. What you need to do is watch over the video and listen back carefully to all the hints that I gave you if you want to learn to factorize them quickly like that in one step. Otherwise, you could go through the process and let's still practice and show you going through the process to get the safe answer. All right, just do it still. So the process would be to multiply the 2n coefficients, which is the 5 times the 4, and 5 times 4 is 20. And what it is that you want factors of 20 that add to this negative 9. Negative 9. So here now you want the factors of a positive number that add to a negative number. Factors of a positive number is either 2 positive or 2 negative numbers. So since you want the sum of the factors to be negative as it is up here, it means that you need 2 negative factors of 20. That's the first thing you need to establish. So we need 2 negative factors of 20. If we can't set those 2 factors of 20, is 4 and 9 right off the bat, then we can try factors of 20 down the list of factors of 20, starting with 1 and 20. We both have them the same sign of this because we must have the same sign. But these now add to negative 21. So no, you don't want that. You want negative 9. So the next 2 factors of 20 will be 2 and 10. 2 and 10 will be the next 2 factors of 20. But and you give both of them negative sign. And when you add them, you're getting negative 12. So no, you don't want 12. So get to the next 2 factors of 20. 3 and what? We're talking about whole number factors. So no, we're not going to use 3. Go to 4. So it's 4 and 5. And the next 2 integer factors of 20. Make both of them negative. And when you add negative 4 and negative 5, you add negative 9. So yes, we're going to split this negative 9x into negative 4 and negative 5x. Let me move this out the way a bit. I will do short. It means then now that this expression, we're going to break the middle term. All right? So we can create a situation we can factorize by parts. So this 5x squared is going to come back and change 5x squared. And this, you're breaking that using these two factors. So that a 9 is that a minus 4x and minus 5x, or you can put minus 5x and minus 4x. Now I'm going to put the minus 5x first, because the 5 factorizes nicely with this one. Then I'm going to put the minus 4x, minus 4x. So I got this one from this, and I got this one from that. And then this plus 4 must come back over here, plus 4. And that is it, I've broken it up into 4 terms. So the matter now of factorizing the first 2 terms and factorizing the second 2 terms. All right. So what is the highest common factor in those 2 terms? That's 5x. I'm going to factorize the 5x out of this leaving with x. 5x out of this leaving with negative 1. Now remember, when you factorize it by parts like this, you must have the same thing in the bracket here and there. So what I'm going to do is put back this bracketed term here first, which is the x minus 1. Then now to know what factor comes here, which has to be a plus value or a minus value. Now, what is the value? I can, for example, divide this 4 by this negative 1 and get negative 4. Or I can divide this negative 4 by x and get negative 4. In any case, we'll put in negative 4 out here. Then what happens now is that the x plus 1 is now your common factor, and you're connecting them with the 5x minus 4. And so when you put that all together, you get 5x minus 4 multiplied by that common factor of x minus 1, which is the same one that we did by trial and error. Same factor we got by trial and error. But I go this question on the value 2 marks, and I say you really want to be able to just flip it like that and pass. All they do. So when you get it the quick or short way, you can test if it is correct. Like for example, you multiply this time this and get the 5x squared. This 5x squared. Multiply the negative 4 times the negative 1 and get the positive 4. And remember that the middle term is the far product and the near product. Far product and the near product add to give you the middle term. So these are just some things you have to remember. But that finishes that question, guys. But all right. Very good.
Yes, sir.
This one now say hence solve this. Hence means that must use the factors to solve this. So the factors of this are these 2. So it means that these 2 now is equal to 0 on this equation. So we can write it 5x minus 4 times the x minus 1 equals 0 in this equation. So then it is either this factor equal to 0 or this factor equal to 0. Now look, if this factor is equal to the 0, then how do we make x a subject? We take this negative 4 and carry it over 4 first, and it will become a positive 4. And then you divide the 5 under it. And so x will be equal to that from this factor. Or from this factor, if this factor equals to 0, then you take this negative 1 and bring it over here, it becomes a positive 1. And so the other x value will be positive 1. And basically those are the solution. Those are the 2 rules. Are you good?
Yes, sir.
Excuse my coffee. All right, this one now wants us to make v the subject. All right, so we have to go to the transpose. So remember, we have an expression like this to make an expression like what is in the subject. We need to expand it out into separate terms. We don't want it to be dividing one another like that. Expand it out into separate terms. Group all the terms that you want on one side of the equation. Everything you want on the other side. And then you factorize to get the p as the subject. The first step in this process, therefore, is to take this denominator and multiply it across here by this w. So then it really becomes w times v and w times the negative 3. I'm going to get w times v is wv, and w times this 3 is negative 3w. And if you want it, you could have put this as vw. Doesn't matter. That's all equal to the right side, mean unchanged. 5 plus v. 5 plus v. Then I want to get this v over here with this v. And I want to get this over on the other side, but there's no v on it. So I'm going to leave this vw and take this v over this side and subtract it. Minus v equals this 5 is already on the right side. And this minus 3w comes over on the right side and becomes a positive 3w. Then now it's a matter of factorizing the v out of these two terms. And so we get v bracket out of this is w. Out of this it is negative 1. So we get w minus 1. And that is all equal to 5 plus 3w. And all we have to do now is take this w minus 1 and divide it on the here. Write this better. Okay. Right. Like we're dividing both sides by w minus 1, guys. The shortcut way is to say you take this multiplying w minus 1 and divide it on this side. Right, so we're going to get the v equals 5 plus 3w over w minus 1. That's the answer right there. Are you okay with that? Very good?
Yes, sir.
All right. Next question. It says, the height of an object is directly proportional to the square of the perimeter. All right. So the first variable h is directly proportional, meaning k times the square root, not the square root of this perimeter, which is the square root of p. That is it. It says write an equation showing this relationship. This is right here. Simple as that. If it was inverse variation, it would be that h equals k over the square root of p. But it says direct. Direct is k times. Inverse is k over. That's it. So this is the equation that I want. All right. Let's see what I want us to do next. K is a constant. All right. So I can maybe state here, so k is a constant. K is a variation constant. All right. Then it says no, given that h equals 5.4 and p equals 1.44, determine the value of h and p equals 2.89. Now, this one is not asking us to find the k. I'm going to do, I told you that there are some questions that don't need to find the k. Is a constant. I'm going to do this method where we don't find the k, we don't find the absolute value of k. So from this expression, we make k the subject by dividing by the square root of p. It means then that the k is h over the square root of p. What that means is that h over square root of p is a constant value. Cannot change. The ratio h and the square root of p is the same for any pair of values. Any pair of values of the h and the p. All right. So they have given us one pair here. And they're asking us basically for another pair where we know one of the parts of the pair and we're trying to find the unknown. So we can set up like this, right? See here, the k is always h over the square root of p. This is known. It means therefore that this h that we want over the square root of this value, this pair go together and this pair go together. So this h over this square root of that, this h over the square root of 2.89, that's a p value, is going to be equal to this h value, which is 5.4, over the square root of this p value, 1.44. So to find the h now, we'll take this denominator and we'll multiply it up on the right side here. So the h becomes 5.4 and the square root of 2.89 divided by the square root of 1.44. The other method would be to actually calculate the value of the k first by plugging these values into here and work out the k. And after I get the k, it's almost like you would write back this equation up here with the known value of k there, and then plug this p value in there. But that's a more lengthy process, and a question like this, we don't need to calculate absolute value of k. But learn how to do the mathematics like that and be efficient. All right, so this is the method we can use when we don't need to find a constant. But then you ask for a constant, you have to practice it that way as well. But good? But okay?
Yes, sir.
Yes, sir.
We just need to work this out though. And then work it out, shift this over. I need to find out value we calculate. Work it out. Let's work it out. Work it out. All right, so that's fraction 5.4 times square root 2.89 divided by square root of 1.44. And that is 8 equals 7.65. 7.6 shift this over a bit. This over there, a bit, over everything. This becomes equal to 7.65. All right, that's it, guys. That's it. Second question done. 9 marks. All right, let's go to the next question. That's your transformation. All right. I know we have done these questions already, but as I said, more maths equals better maths every time. So the diagram below shows 4 shapes, P, Q, R, and S, and a square grid. All right. So what's it gonna happen? That this is gonna be your original object. You're gonna have to see what transformation maps to R, what transformation maps to S, what transformation maps to Q. All right. That's how these questions usually go. See, it says describe the single transformation which maps P onto Q, then R, then S. So looking at the diagram, we're going to figure out what type of transformation it is, each one is, and components of the transformation. Remember, you cannot just name it. It says describe fully, and they want one single transformation. All right, let's look at how we go from P to Q first, which is right here, P to Q. When I look at that, there is some turn. It's actually a 180-degree turn because this side, this piece down here that was pointing south, on the image is now pointing this way. So we know that the thing turn around, it's a 180-degree turn. Whether that be clockwise or anti-clockwise, it's a 180-degree turn. All right. How I know it's not a reflection. Right? How do I know it's not a reflection? Because in a reflection, orientation would be reversed. So if you choose a couple points, for example, let's say this is A, B, and C. I'll put those similar points on the image over here. So this point A would now be here, A prime. This point B would be nose out here, B prime. This point C would be this point here, C prime. Now, if I check the orientation of these three, right now it is clockwise. If I check the orientation of these three, A to B to C is still clockwise. So I know it's not a reflection because the orientation is still the same. Once the orientation is still the same, it's not a reflection. All right. So because this turn now, it's a rotation. It's clearly not a translation, and it's clearly not an enlargement. I will just deduce that it is not a reflection because the orientation is not changed. So therefore, it is a rotation. All right. So it's a 180-degree rotation. So what we need to do to describe the rotation to give the angle, the direction, and center. So the main thing we need to find out is the center of the rotation. Remember, the center of the rotation is a point that does not change under the rotation. All right. So this point up here, for example, rotate up to this point. This point rotate up to that point. So basically go like so about some center point. And the center point and invariant point, you know, see them join right here, the two images join right here. So your center point must be on this line. Right? You can literally figure it out, you know. Right? You can literally figure it out because this point is now up here. And this point is the other way. This point up here is now down here. All right. What we can do is join two other corresponding points, like for example, this and this. And join them like so. And that this point would have rotated around to here. So where those two lines meet, that's where the center of rotation is. Right here. Right here. The center of rotation. All right. But this point rotated around to here. And as we said before, this point rotated around to there. And basically that is it. Right? So because I want to join 80-degree rotation, we could do it that way. So the center of rotation is that point that is in blue. And we need to use that as a part of the description. What's coordinates of that point? It is 7, 7. This point is 7, 7. 7, 7. And we're going to see it's a 180-degree rotation about the point 7, 7. I'm going to see clockwise or anti-clockwise. We're just going to see clockwise. Doesn't matter if you see clockwise or anti-clockwise because a 180-degree rotation, clockwise or anti-clockwise is the same result. All right, so anyone who use it, they're going to give it a mark. So we're going to say first one is 180 degrees. Let's just say clockwise. Clockwise rotation about the point 7, 7. Now, description rotation must always be described this way, where you give the name of the transformation, rotation. You're going to have to give the 3 components of rotation, which is the angle, the direction, and the center. Once you describe a rotation, you must give those 3 things: the angle, the direction, and the center. Remember also that clockwise rotation is negative rotation. So we could have said a negative 180-degree rotation about the origin. If we want to say it was clockwise, we have used negative 180 degrees. That finishes that one. Better go to that. Are you okay?
Yes, sir.
All right. Then we're going to R next, all right? From P to R. Let's look at it. P to R next. So P to R. Now that one is a reflection. Orientation is reversed. Right? Because, for example, this point to this point to this point, around this way. But this point now these corresponding points are now this way. So we know about reflection because orientation is reversed. Right? And the mirror line is going to be equidistant between the between corresponding points. Equidistant between the corresponding points that I give this around. So we need to find the mirror line. So the mirror line is going to be halfway between these 2 points, for example. Right? Which is somewhere here. That's a midpoint between those 2 points. So the mirror line is somewhere, look like it's on this one. Halfway between these 2 as well. Right? This is 3 units, 3 units. So the mirror line clearly is this red line that I'm drawing on. And that's a vertical line. If you extend it down the pass through 1, and vertical lines carry an equation x equals a number. In this case, it's x equals 1. The vertical line passing through 1. When you describe a reflection, all you need to do is state the mirror line. In this case, the mirror line is x equals 1. There's a reflection in the line x equals 1. That's what the second one is. At x equals 1. Simple as that. A reflection in the line x equals 1. That's it. All right, that's an easy. Let's go to the next one now, which is enlargement. And we can see S. S is actually enlargement. So you're going to that larger object. So this one goes to this one. Let me take these off now. Let me take these off the diagram. So we can, mark it out. So remember now, enlargement has two components, a scale factor and a center. The scale factor can be positive, it can be negative, it can be a number greater than 1, or it can be a fraction. Right? Now, this thing clearly got larger. So you know that the scale factor is a value greater than 1, it's a whole number. And it's also positive, one is positive because the image and the object, they are pointing in the same direction. So I know the scale factor is positive. Now, what is the value of the scale factor? You can look by what multiple it increased, the image increased to that object. You just need to look at maybe one dimension. For example, here, 1 unit on the object, it increased to 2 units. That's a multiplier of 2. So the scale factor is 2, positive 2. All right, positive 2. Then to find the center of the enlargement now, we need to basically construct lines joining corresponding points and extend back to where they meet. So for example, these 2 points are corresponding points. So we can basically go like this. That to be aligned to the center of the enlargement, joining these 2 corresponding points. We can maybe use this one and this one. Or we can use this one and this one. And then use your ruler and line it up, right? So we'll like so line up these 2 like that. Let's extend it back. All right, and I'm gonna check. It move further, like it up here. All right, when you reach to the ruler, get it precise, right? Get precise. I'll be my prayer, but I'm gonna check. Remember now, scale factor does not only affect the size, it also affects the distance from the center of the enlargement. So if this is the center of the enlargement where those 2 construction lines meet, then the distance will have also been doubled. What that means, for example, the distance from this center of enlargement to here is 1, 2, 3 units. That would have to double to 6 units down to here. The scale factor is really 2, which is what happened. 1, 2, 3, 4, 5, 6. So you see, the distance from that center of enlargement was doubled by a scale factor of 2. So you can accept that this is in fact the center of the enlargement that has coordinates 7, 11. This is now 7, 11. Center of the enlargement, scale factor 2. So let's describe it. Scale factor of 2, the center of the enlargement is 7, 11. And let's do that description. So this now is an enlargement of scale factor 2 and center. You can say about the center, about the point. Just write and center. Then we say about the point. The point is 7, 11. Center point is 7, 11. That's the answer right there. But you could also say about the point 7, 11. Center point. Center point. 7, 11. But good with that? So it's it for enlargement. Right?
Yes, sir.
Yes, sir.
The 2 components of enlargement, scale factor and center. All right, simple as that. All right, I finished with that one. All right, next part says, and we provide on page 10, this page, the next page, and the same page here. It's the same page. I don't want us to. They want us to draw the image of the shape P after an hour translation by this vector, negative 2, 3. Now this vector of negative 2, 3, this negative 2 means minus 2 units to the left. Like starting here, the point is going to move 2 units to the left, and this 3 means 3 units upwards. 3 units upwards. That's minus 2, and that is a 3. That's what that translation matrix means. We're going to move each point. All right, so a point here will move to here under this translation. So we're going to move each point that way, or we can move one point and then draw about the same shape around that one point. When it's a translation, we're doing it's okay to be that way. All right, so let's look. So it is what? Minus 2, 3. Let's get this out. Minus 2, 3. So let's say we're using this point as a reference point. Move that point and then draw about the same shape around that point. You have to check your scale carefully. Each of these centimeters are unit horizontally. Vertically, each of these centimeters is a unit. All right, so we're going what? Minus 2, 3. So it's 2 to the left, 2 to the left, and 3 up. So 1 to the left, 3 up. 1, 2, 3. So this point is coming to here. Make sure again it's minus 2, 3. So this point, as I said, is coming to here. So now that we know where that point is going to go, this point, if you can draw the same shape around this point, so all of what you can do. So I'm going to draw back. This length here, which is 1, 2, 3, 4 units long. This horizontal piece is 4 units long. So it's 1, 2, 3, 4. And then this piece is 2 units up. Then this is 1 unit on top here. Then this is 1 unit down. And then you come, oh, then you have 2 units across here. And you complete the shape with that piece. And that one is our final image. They said what to label it, I will tell you what to label it. Label it like T. So just to label it. But good at that? But
Yes,
okay with
sir.
it? All right, and let's finish another question. That finishes another question. I'm going to not do all the questions today. I'm going to do some today and then do the rest of them today. All right, so anything you get wrong, anything you didn't do, you can go and do it. All right, go and do it. So I don't bombard you too much on that one. All right, so number 3 now. Number 3 is a function system, as you can see. It was two linear functions, f and g. First part wants us to find g of a third. We're going to put a third in the g function right here. It's simple as that. And so this becomes putting a third here, let's say, becomes 3 times a third minus 1. But 3 times a third is 1 minus 1. That works out to be 0. All right, next part. F to the minus 1 of negative 3. I showed in the last class a way to find this. You put equal n, and it's a minus 3 equals f of n. And then put f of n equals minus 3 and solve for the n, right? But I'm going to use the other method today just to give a variety. Here we're going to use the method of find f to the minus 1 of x first. Then put the minus 3 in. Using that method. But any method you use, you're gonna have to do the same transposition. So I want to start by saying the f equals. To do this part, we're going to call it f. Call the function f, which is 5x plus 7. F equals 5x plus 7. We're going to inverse it. We'll inverse it. The f becomes x. And this x becomes x to the minus 1. So it's 5x to the minus 1 plus 1. Then we want to make this a subject. So we're going to subtract this 1 first and then divide under the 5. So we're going to get x minus 1 and then take this 5 and divide it under here. That is your f to the minus 1. I'll put it back off x on it now. So I've done this part. So to find f to the minus 1 of negative 3, now putting a negative 3 in here and in there. All right, so we can draw a conclusion. Let's use the purple. So therefore, f to the minus 1 of negative 3, that negative 3 is coming right here. So it's minus 3 minus 1 divided by 5. Minus 3 and minus 1 is negative 4. This works out to be negative 4 over 5. Negative 4 over 5. And that is our answer. That is it. Very good.
Yes, sir.
Okay. Want to see the other method still? Want to see the other method on the side here still or no good?
Yes, sir.
Let's do the other method. I want to see if I can let's do it. All right. So the other method we said is we will call this n. All right. We call that n. It's your f to the minus 1 of negative 3. Put it equals some number n. Try to find what that number n is, right? We'll find n, you'll find the answer. So if f to the minus 1 of negative 3 is equal to n, it means that we transpose the f to the minus 1. So negative 3 becomes equal to f of n. F of n now is formed simply by putting n in the f function, f of n. So it means then that minus 3 is equal to 5n plus 1. Right? Put the n now is 1. So make a mistake over here, so this is 7. I could also do it another way. This is actually 7, not 1. It's a 7, not a 1. It's a 7, guys. It's a 7. Just write it out on the wrong number. This is a 7. So this is a 7 as well. Right here, that's a 7. It's a 7. So this is a 7 here. And so this is a 7. It becomes negative 10 over 5 is negative 2. Negative 3 and negative 3. Negative 7 is negative 10 over 3. Negative 10 over 5 is negative 2. Negative 2. All right, let's see. So this is actually a 7. Putting a 7, let me do it the other way. That's 7. All right, 7. So we're trying to make this a subject. All right. So when I throw over the negative 3 here, throw over the 7 here, I mean, throw over the 7, get negative and then divide another 5. So you get by the same thing. So there will be negative 3 minus 7 equal to 5n. Then take the 5 and divide it under here. You're going to get the n equals negative 3 negative 7 over 5, which is the same thing we have right here. And so the n will be equal to negative 2. Once you get the n, that is the answer for that. That's the other way to do it. All right? Therefore, x to the minus 1 of negative 3 is equal to negative 2. All right, so you see, good thing follow mine and do it another way. But we were doing the right process though, just that we basically wrote down the wrong value. And I looked at it, I saw 1. It was really a 7. That is it. All right, that is that. And that tells me that nobody did the test that, and nobody couldn't say, sir, that is a 7. That they did do it. This question says the line L is shown on the grid. So they show this line. I like questions like this because you can look at the graph, you can count off the rise over the road and get the gradient, and can, for example, see this y-axis intercept right here is 1. So the C equals 1. I like this kind of question because very, very easy to calculate a lot. It says write the equation of this line form y equals mx plus c. See? Right here, just C value. So C equals 1. Then you need a gradient. To get the gradient, you just need to count the rise and the run between any 2 points. For example, I can use these 2 points here. Any 2 points that you know the coordinates for sure. Check the gradient, make sure the gradient, you get the units on the grid properly. So every unit there is 1. Every grid is 1 unit, or every centimeter is 1 unit. So what is the rise over the run to this? The rise 1. So the rise is 1, and the run is 2. Rise is 1 and the run is 3. So the gradient is 1 over 3. Rise over run. Right? So this is the rise and this is the run. And the gradient is rise over run. So the M on this question is rise over run. You can use any 2 points on the graph, which is 1 over 3. So you take this, I put it here, and take the 1 and I put it there. All right, so easy enough. Equation is y equals a third x plus 1. Nice and easy. What are we going to do that? But okay?
Yes, sir.
All right. Next part now says the equation of a different line is this now. So if you look at this, the y-axis intercept is 8, and the gradient is -2. All know that because y alone is a subject right there. It is already in the form y equals mx plus c. This one. So it means then that for this line, it passes through 8, and the gradient is -2. It says write the coordinates of the point where it called the x-axis. Easy. On the x-axis, y equals 0. And so on x-axis, y equals 0, you can put 0 right here. It means that the expression becomes equal to 0. Sorry, on the x-axis. So minus 2x plus 8 is equal to 0 on the x-axis. And so we can transpose this 2x over here, make it positive. So 8 equals 2x. And when we divide by the 2, you get the x equals 4. So it means that the point on the x-axis, the coordinates of the point, and it's one both coordinates. So the point on the x-axis that I want. This is the x value, 4, and 0 is the y value, 0. That's the point, 4, 0 on the x-axis. Then it says, no, right on the coordinates where the q crosses the y-axis. On the y-axis, x equals 0. That's y-axis intercept on the equation anyway. It's 8. Right? But if you look at it, then you put the 0 right here. You're going to say that the y equals 8 anyway, right? So the y equals 8. So 0, so x equals 0, y equals 8. And so the point that we're talking about is 0, 8, 0, C. That is it. That's amazing. It says, on the grid, draw the line Q. So draw the line that passes through 0, 8, and 4, 0. All right, 0, 8, and 4, 0. So it passes through this point up here, 0, 8. Let me take these down. Put the right hand on all the way down here. So put it down this. Here and here. As 1, 2, 1, 2. As one. All right, so 0, 8 up here. So here's the blue. It passed through 4, 0 down here. So just use the ruler and draw the straight line through that, right? But we could also draw the graph using the gradient. Remember, when the gradient is, what was the gradient again? What was the gradient of this line again? -2. -2. Minus 2 is same as minus 2 over 1. This means rise minus 2, run 1 to go from point to point. So starting at here to get to another point, with rise minus 2, run 1. So when the rise is negative, it means that you go down to run 1 to here. Down 2 again, run 1 to here. Down 2 again, run 1 to there. Down 2 again, run 1 to there. Is that all those points are on your line. So we could have gotten like that. But as I said, we could have just used these 2 points that we got on the system and draw the line anyway. All right, so basically that is it. So looking at a line that goes like this. This is the line, other one. This is the line Q. This line is Q. It's just the rise and the run. These are different color for the rise and the run. These are different color. Rise negative 2, run 1. 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 All right. So down and across. Down and across. Down and across. Down and across. All right. As I said, we could have just used these 2 points. Anyway, the question must ask us about this point then. Must. Right here. With the intercept. Must. Question must ask us about that point. That's also the first piece question there. That point is 3, 2 for the mean. All right. That point is 3, 2. 3, 2. 3, 2. All right. Let's see what they ask about it. So draw the line. Right? Draw the line already. Then it says now, complete the statement below. According to the graph, the solution of a system of equation consisting L and Q in the 2 lines is. In other words, we do the intercept. The intercept at the point that we just marked a while ago. So we solve these 2 equations simultaneously. We have line L and line Q simultaneously. We're going to get this point. We're going to get these values, 3, 2. Right? So it will be 3, 2. X equals 3, Y equals 2. Or you could put 3, 2. That's what they mean. That is it. Are you good at that?
Yes, sir.
Right. What a bright. What a all right. Number 5. We discussed that other day, I think. Did we? No, I don't. No, I don't think we did discuss that when we did statistics practice. All right, good. It says, a school nurse records the height 8 centimeters of each of 150 students in class A. I'm going to discuss that in the other day. All right, who was vaccinated. Table below shows the results. So this is 150 students. I want to put 150 down so don't forget, right? The total students, 150. So this is supposed to add to 150. And they give us these values as boundary values. So if you notice, this upper value and this lower value is the same. And then this upper value and this lower value is the same. But these are the boundary values they give you. One is boundary value because where one boundary ends in one group, the other group starts at that same value for the continuous data. Notice the 80 is included in the first group, but the 80 is not available in the second group. All right, so anything that approximates to 80 is going to come in this first group. All right, so they give us that table. Then it says no, compare the table below and use information to calculate an estimate of the mean height of the student. Give your answer to 1 decimal place. So I've started it for us. To calculate the mean from group data, remember, what you have to do is use the midpoint to represent the group. Why? Because of the 4 students in this group, for example, don't know the actual height of the 4 students. They don't know. Yes, I know the data is presented. And that's why we're only calculating an estimate of the mean. We can't know the precise mean. And CSEC will ask you that from time to time. Why are we calculating an estimated mean? Because we don't know the actual height of the students in the groups. For example, the 4 students in the first group, we don't know the actual height that they measure. All we know is that they measure between 60 and 80, inclusive of the 80, but not inclusive of the 60, greater than the 60. All right, so what you do, you assume that all of them measure the midpoint height, all 4. That's the assumption that you make in order to estimate the height. So basically saying, okay, since I don't know what they actually measure, I'm going to use 70 midpoint height for all of them, which is not true. Just an estimate. And you're doing the same thing for all the groups. All right. So we need to complete the table by putting a midpoint value for this one. If you notice, these are going up by 20. So this will continue to go up by 20. So it's going to be 130. And then to get the value here, we need to multiply these two. What we're saying here is that all 67 students in this group, each of them measure 130 approximately. So the total height of all those 67 students can multiply to get this value, that last column. So you need to multiply those. So you prepare F times X. And this is a way of summing the height. That's your sum column. It's a way of summing the height. You multiply the frequency by the score, the midpoint score. All right, so let's get the calculator, multiply those two values. And it is 67 times 130. That's 8710. Now we're gonna need a sum. Calculate we need the sum of the sum, right? We need the sum of all the students approximately. Sum of the height. So we need the sum of FX. Let us work it out from now. So we're adding up all these values now. All right, so it's 280 plus 1800 plus 3850 plus 8710 plus 3000 plus 680. And so that is 18,320. So when I can speed and shift this over a little bit. 18,320. 18,320. Is total height of all 150 students, and this is the sum of them equals that. That's supposed to estimate the mean, right? Right here. So the estimate of the mean, approximately sum of fx, this is the sum of the sum over the sum of f, which is the number of students. So it is 18320. That's approximate height of all the students, and there are 150 students. And so when you do this division, you're estimating the mean height, 18320 over 150. That's 122. And it's a 1 decimal place. One decimal place. So 122.1. And the mean field of measure centimeters. 122.1 centimeters. Put this over it. So 122.1. You have to put the unit of measurement for the height centimeter. That's like the mean height, right? The mean arithmetic mean height. That is it. Very good. But okay. Yes,
Yes,
no.
sir.
All right. Next part says class B. In class B, the mean height is 123.5. I remember this. And the standard deviation is 29.87 in class B. For class A, the standard deviation is this. All right. So they want us now to use this information to provide a response or comment the distribution of height of the student in class A and class B. So CSEC will ask this from time to time. Notice there's only 1 mark first. So you're really just looking for a statement. So it's simple. Standard deviation is a measure of how the height of a student vary from the mean height in the class of students. All right, that's what it is. And the one with the highest standard deviation is one where the height of the student vary more widely from the mean height. The lower standard deviation or the smaller standard deviation means that the height of the students vary more closely from the mean height. The important thing with standard deviation is that it is measuring variation from the mean height. So you must see that. When comparing two standard deviation values, you use one as a reference and compare it with the other one. All right. So let's make a note of it now. So class B, just to make sure, and class A. So and see which one is wider. The one that is higher standard deviation is wider. Class A, class B, just to make sure. So the class A value, class B value is this. No, that's the mean. The standard deviation we want is this. 29.87. I'm not interested in the exact value of the mean, right? We know that it varies from the mean, but we don't need the information of the mean. Standard deviation in class, for class B is this one over here. Get it right. Yes, I shall get it right. Class B is this one. We just gave us class B over here. Class A standard deviation is this smaller one. 21.38. We put them down there. All right. So simply put, since this one is higher, it's more widely spread from the mean. Compared to the class A, and since one is lower, it is more closely spread or less widely spread because it's more closely spread. When it is smaller, it's more closely spread. When it's larger, it's more widely spread, more closely. The smaller one, smaller standard deviation means that the height is closely spread from the mean height. You have to write out a statement in here, right? All right. So if I'm going to use A as a reference compared to B, I'm going to say the heights of the class A students using class as reference are more, if class A more closely spread, are more closely spread from their, it's class A mean height as compared to the class B students. And that is all. If you're referencing from class B, we said that the height of a student in class B are more widely spread from their mean height as compared to the students in class A. If you're referencing from class A, then their height are more closely spread. If you're referencing from class B, then their height are more widely spread. And that is it. Everybody good? Are you okay with that?
Yes, sir. Yes, sir.
All right, good. All right, let's continue. And down here now, they said, complete the cumulative frequency table below and use information, construct the cumulative frequency curve. All right, so this one now we are going from table to curve. Remember, you have to learn how to go from curve to table. You've been doing that in recent times. You have to learn how to go from curve, cumulative frequency curve to table. Pull it up, pull pull the table apart, get the individual frequency, and plot the curve from the table. Populate the table from the curve. I can learn how to do that, but this one just wants us to go from curve to table, from table to curve, which is the easier way, to the standard way. So in recent times, they've been asking us to go from curve to table. So give it a curve and you have to populate the table. All right. So we just need to fill in these two, which is, remember now that the cumulative frequency column is your counting column. You're counting the students as you go from group to group. All right, you're counting how many students have a height less than or equal to these upper boundary heights as you go from group to group. All right. So you have 24, see, 20, that 24 is some of those two. So now to get this one, we need to now add up all of these. I need to add this one to this. All right, so to show the calculation here, it is the 24 we have so far plus the 35 more that we're adding in this group to get the total number of students up to this point, which works out to be 59. And if we check it, the 59 plus the 67 is supposed to give us that. All right, 126. And then now, the 126 plus 20 gonna give us this one now. With 126 plus 20 more students gives us 146. And 146 plus this 4 is what is giving us at 150. So that is consistent. All right. And then now, remember, cumulative frequency graph, guys, is plot using the upper boundary values with the cumulative frequency values. Remember that you must have the habit of bringing the graph down to 0. And the value before this one would have been 60. And 60 as a cumulative frequency of 0. So you carry your graph down to 0 at 60. All right. What that means is that no student had an height less than or equal to 60. That's what it would mean. All right. That's what it would mean. All right, let's continue. Draw the graph over here. All right, so the plot some of the points for us already. See, they put in the 60 down at 0 here. That was not a point, that's a point that was added. So the 2 points that I'm missing are the ones that we added to the table. So it is 120, 59, and 160, 140. Write them down. So those points are 120, 59, and 160, 146. These are 2 points we need to put on the graph. Copy them down here. And add them to this graph. All right. 120 is 120. So 120 is 120 is a frequency of 59. With a frequency of 59. So you have to read the scale of the graph. Properly, this is where 59 is. So look at this. There are 5 lines between 0 and 10. 5 lines between 0 and 10. So each line is 10 divided by 5. Each of these little lines is 2. See? 2, 4, 6, 8, 10. All right. So each of those like a small line is 2. On the horizontal axis is 20. Interval of 20 and it's 10 lines. So it's 20 over 10. Each line is 2 again. So it's 60, 62, 64, 68, 60. Come again. 60, 62, 64, 66, 68, 70, and so on. So each of those line is 2 on each axis, right? So we're plotting this point 159. We want 59. So say 50 or so, and say 60 or so. So right here, so 58, you know. So 59 is right in between there, so everything important, to be precise. 120 line is this one up here. So it means that we're coming right to this intersection right here. So that's where it's going to be. Right? So that point. The next point, I'm sorry, 160, 146. So 160 is this line, 160 is this line up here, this one. So it's marked is 160 line. We're looking now for 146. All right, so 140, 142, 144, 146 is this, 146 is this. So come across this one. And they're coming here. This is the point. That is it. All right. Basically, then, we draw a smooth curve through those points. We will have our graph. Let's try to take it through. A smooth curve through all these points here. Smooth curve. This one as well. Right, let's try it. Let's draw a smooth curve through those points. And let's try it like this. Up here. Over that. Here. Lots. All right, good enough. But okay with that?
Yes, sir.
Yes, sir.
And I want us to read something from it now. That's a curve, that's an O game. It says find an estimate of the median height. How many students are there again? 150 students. So the median height is the height of the student in the middle. Remember, these are the students. These are the heights that they measure less than or equal, right? So if there are 150 students, the median height, portion of the student with the median height is half of 150, which is what, 75. So for the 75th student. All right, so this is 70, this is 80. The 75th will be right here. That now is the position of Q2, which is the second quarter, is also the median. That's a position of its students. So to find the height, find the height that 72 students measure less than or equal to. They will come across on the graph like this. An approximation. Say about there. And then read it down onto the x-axis. And see what that height is. That half of the student measure less than. And that's 124. So 120, 122, 124, 126, 128, 130. All right, so that's 124. All right, so that's 124. 124 centimeters is the median height. Right there. That's Q2. All right. Let's write it down here. 124. All right. 124 centimeters. See, these lines on the graph, I believe in them to show how I get my answer, and these marking down here, I'm leaving them as well. Examiner must see how you got your answer, guys. Draw lines in the graph. Next one said the probability that a student chosen at random would be taller than 130. Taller than 130, greater than 130 centimeters. So you need to first find how many students are taller than 130. But what the graph is showing how many less than or equal to 130. The rest of them will be taller than 130. So I'm going to find 130 on the graph first and see how many less than. This is a less than or equal to height graph. Right? Why? Because remember, we use these upper boundary values which were on the less than or equal to side of that boundary. All right, so looking for 130. Right here is 130. 130 or so. The graph is going to show you how many less that. The height that you want is the one up here. Right? You want to know how many people up here. So the graph going to show you how many people less than or equal to 130 first, and the rest of them more. All right, so measure more. So come on the graph on this 130 line right up here. Come right up to here. So, and it looks like he's right. You don't quite reach this line, you know. So right before that one, I'm gonna put it here. And then I'll move these out the way. And this now looks like 138. This is 138. That makes it 138. So to the rest of them, but 138 measure less than it, you know. The question asking us for who measure more. Right? So we're talking about up here. 150 minus 138. That's what we want. What is that? 12. That's 12, right? Everybody paying attention.
Yes, sir, that's so.
All right. And it's a probability one. So it's 12 out of the 150. These are the ones who measure more than the 130 centimeters. But 38 students measure less than or equal to 130. So the rest of them, which is the ones up at the top here, those are the ones who measure more. All right. So that is 12 in the 12 years. 12 of them measure more. 12. More than the 130, the top 12. All right. So probability of getting one of those is 12. Probability of being greater than 130 centimeters. That's 12 students out of the 150 students. That can be simplified. Okay, I can divide this by 3. Divide by 6. Oh. You can simplify this into lowest terms. But I simplify it too. It becomes divided by 6. Divided by 6 becomes 25. Now becomes 2 over 25 divided by 6. But I agree with that.
Yes, sir.
Yes, sir.
All right, so that is it. That finishes that question. All right. So we'll come to this one. I think after I finish this one, we might stop and then continue here tomorrow with 4 questions, 7 and a 3 section to use. I'm not gonna finish today. It's number 6. Number 7. All right. This particular question. Let's just finish off today with this question. So yeah, just 6 questions to look over today. Show you them right. We do anything you got wrong. I don't see a lot of persons. I don't see enough persons send me answers for the multiple choice. I think I might leave another day before I send those answers. I'm sorry. All right. But let's throw up this one now. This is a solid geometry question, right? Remember the formula govern this topic. 3 formula. Right? Volume is cross-sectional area times length. Curved surface area is perimeter of the end times the length. And then total surface area is the curved surface area plus the two end areas. A means end area. This is the object of uniform cross section. This is the end. These two ends are the same. So the L is this. That is the L. The A would be the sum of the area, that rectangle or square and this semicircle like this. That would be the A. And the P would be the perimeter of this end, the distance around the end, over here, down this curved section, and up here. Remember, this piece across here is not a part of the perimeter. You know, you don't add that to the perimeter. Perimeter of the end with the distance around the boundary of the end around here. We're going to use this formula for the curved surface area. Curved surface area, remember, is the area around the side of this object. This is around the side of it. The curved surface. I don't know if this question want that, but I'm just telling you still. All right, because it's a topic that we need to listen. All right, so this one says, the diagram below shows a solid with a semicircular cylindrical base. Semicircle means half of a circle that is this. With a rectangular prism above it. So this is a rectangular prism above it, right? A semicircular base and a rectangular prism. Is that object uniform cross section? It says the diameter of a cylindrical base and the width of the rectangular prism is 4. So this is 4 across here. So it means then that the radius we're working with down here is 2. Let's make a note of that. The R equals 2. I tend to work with the radius we're dealing with circular measures, right? The R equals 2 centimeters. And this cylindrical, semicircular, semicylindrical shape. All right, so the R here is 2. So this is 4 as well then. That's 4. This is 4. So it's actually a squared 4, 4, 4 foot. This is 12. It's 12. All right. Let's say this is 4 across here. So right here is 4 as well. All right. So the 4 by 4 end. I just want to put that in the diagram. So, oh, see it over here. So we have it over here. The 4. All right. Right here. So let's take the total surface area. Let's see, total surface area. They're giving us some help. It says the surface area of a cylinder, radius r, is this 2 pi r square, which is the area of the end. But remember, the semicircle we have now, plus 2 pi r. But the problem with this is that this is for if we had a full cylinder, right? But that's not a full cylinder we have. It's a semi-cylindrical cylinder. So I would not go and depend on this, right? Don't need to depend on it. All right, to get the surface area. You can use the formula that I gave you. All right. So we're going to use the approach that we use that I showed you. We're going to say the total surface area. That I want, TSA. Let's break it down. Is equal to the curved surface area plus the two end areas. The curved surface area is the perimeter of the end times the length plus the two end areas. That's the total surface area, right? TS again. TSA. So I'm going to use an approach where I work with the perimeter of the end. I already know the length. I need the area of the end. Let's work those out for the shape. All right, work out these parts. I already know the L. The L already is 12. I know the L already. The L is the distance between the two ends in the shape. So the L on this is 12. That's right. L equals 12 centimeters. All right. So what is the L? What is the perimeter of the end and what is the A? That's what we want now. Let's work out the A first. The A will be the sum of this area and this area. Let's work it out down here. So the A will be equal to the area of the semicircle. Let's call it 1 and 2. We just call this 1 and 2. So it will be the area of part 1 plus the area of part 2. And the area of part 1 is a half of a circle. This is a half of a circle, right? So it will be half of pi r squared. And then the other second part is a square. Just 4 times 4. 4 times 4. All right. I can put in values on this and I'll put the 2. Remember, this is 2. Put the 2. Right? This formula really that we're using here is half of pi r squared. Because half of the area. We can put that value here as the end area. We can pass. That's over here. All right. So that's they tell us to use for what did they tell us to use for pi? They didn't tell us to use anything for pi in this question. No, so one is a pi in the calculator. All right. So for this calculation now, putting it in the calculator. So 0.5 is a half times pi times 2 squared is 4. And then we're adding this 4 squared is 16. So we're just adding 16 to that. That works out to 22.28. Let's work with 3 significant figures. Put 22 point. Let's put 22.28. Work a little bit more than the 3 significant figures for now and come back to 3 significant figures in the end. So come 22.28 centimeters squared. Is the perimeter of the end. Is the end area, sorry. Next we need is a P. This is the perimeter of the end. The P. Written red as well. So the P becomes equal to, it becomes this half of a circumference of a circle plus these 4 sides, these 3 sides. Look at it in. All right, let me look at it again. Show you. The perimeter of the end is these 4, this 4, 4, and 4. Cannot include this part in the perimeter. You're going around this the end of it to get the perimeter. So it's 4 plus 4 plus 4 plus this half of a circumference. Circumference is 2 pi r. So half of a circumference is half of 2 pi r. All right, so it's not difficult, guys. So we're going to put the perimeter of the end as 3 times 4 centimeters plus half of 2 pi r, and r is 2. Right? R is 2, half of 2 pi r. And this r is 2. Remember the 2 pi r in a different color. This is 2 pi r that we are using. Half of a circumference. And we'll put this in the calculator and see what the perimeter of the end is. Do the mathematics easily. This is 3, 4, this is 12 plus, work this out now. This is really half of 2, the 2 gone in it. And so we're just left with this pi times 2, which is 2 pi. We're just going to add 2 times pi, 2 times pi, or just 2 pi, 2 pi. But this just works out with 2 pi. With this half cancels this 2, and put 2 pi right here. That is it. So it's 18.28. That's 18.28 centimeters is the perimeter of the end. So I'm going to take all of that now and plug it back in this. And so the total surface area equals perimeter of the end, which is this 18.28 times the length, which is 12, plus 2 times the end area. The end area is this 2 times 22.28. And this now will quickly give me total surface area and avoid all the complication and things that I'm trying to give you this form. I don't need it. All right, don't need it. Just put this in the calculator now and we're good. So that becomes 18.28 times 12 plus 2 times the end area of 22.28 is 100.28 twice. So it is 263.92 centimeters square is the total surface area. But okay with that? Very good.
Yes, sir.
All right. Okay, so I will get the point 2 probably the pi here and the pi here as well. So let's see point 2 Our adding four numbers to those values. That's why we get the point 2 class. All right. That's that. Then it said, no, calculate the volume of a solid. Easy. The volume of a solid is the end area times the length. These 3 marks are given for that. We have a component that we want. We have the end area already up here. 22.28. And have the length. So this. So the volume of a solid is 22.28 times 12. 3 easy marks for that. I really did the bulk of the work up here. And see, this was 4 marks for this. It's hard to get a question given so many marks. And it says 22.28 times 12. That is 267.36 centimeters cubed the volume of that solid. Very good. Very good. Say yes, no man. Somebody say yes.
Yes.
Also. No.
Yes, sir.
I'm good for true, you know. Go and work over the question and I'll get it. Go and work it over. And you have to practice use this method. Every time I give people this question, a question like this to do, they're adding up, for example, total surface here. They're adding up this area, work out this area, work out the area around here. So they work out the area and adding up. You're wasting time. You are wasting time. Right? Learn them 3 formula, govern everything on this topic. Learn to do it that way. Come on, man, do the question easier. Stop wasting time. Right? Especially for total surface, you have people still adding up areas of the individual sides. Like you lock your brain. Come on, man. Come on. We want to do these questions. Get them out the way quickly. We're doing too much work on these questions. Come on, man. Practice it this way. It's easier. Let's go. This one says the solid is made from gold. So the solid is made from gold. 1 cm cube of gold has a mass of 19.3 grams. Right? And then the cost of 1 gram is $42.60. Calculate the cost of the gold that make solid. All right. So this says 1 cm cube is this amount of mass. Then now 1 gram is this amount of money. All right. So what we can do is find out how much money for 1 cm cube. So this is just some multiplication. Just multiply and we'll get the answer. That's what it is. So 1 cm cube is equivalent to this amount, 19.3 grams. Well, 1 gram is this amount of money. 1 gram is this amount of money. So this amount of gram, you have to multiply by this to get the amount of money. All right? Right, so 1 gram is equivalent to this amount of money. That's what they say. Because what we know is the volume of the gold. We want to know how much money for 1 cm cube of the gold. By just now multiplying this and that. So it means that 1 cm cube of gold is equivalent to much money. This amount of grams times this amount of money. So 1 gram is this amount of money. So to get too much money for this, we'll just multiply by the unit price over there. So we're gonna put 19.3 times this amount of money, which is 42.62. That's the amount for 1 cm cube. So multiply that up for everything, multiplying up, 19.3 times 42.62. That's the amount of money for 1 cm cube of gold. 822. I'm going to put the 0.566 to keep the accuracy. I'm not going to correct it yet, just to maintain the accuracy. I could have done the calculation by just multiplying the three values. Because now that you want the amount of money for the gold, we're going to use this is the volume of gold. So if this 1 cm cube is this amount of money, then the total volume is obtained, and total money for this volume is obtained by multiplying this now by that. Right? It's almost like a ratio. So we can say, therefore, 267.36 cm cube, which is the amount of money in that bar, is equivalent. You multiply this by that, equivalent to this amount of money, 822.566. Let's keep it 3 decimal places times this amount of gold, cm cube, 267.36. Just show some calculation. So we're going to multiply again. Multiply the three values that they gave us. This times this times this. Up here, multiply each other to get the answer. But just trying to make you understand it. So multiplying that now by the 267.36. And so we are getting much money that 419,921.25 dollars. That is the amount of money for that bar of gold. But I go to that, you don't do too much work up here. You just multiply the three values. You could say you multiply the three values, right? Multiply this times this times this. Right? 1 cm cube is this amount of mass. 1 mass, 1 gram is this amount of money. So to know how much money for the 1 cm cube, so multiply the money by these two first. Then no, because it's this amount of cm cube, multiply that result now by this again. So it's 3 multiply these three values to get the answer that we want. That is okay. All right. That's it for today, guys. That is it for today. And we'll pick it up back tomorrow with the other half of the paper from number 7. All right, very good. I might start a little bit late tomorrow, but I'm coming online, right? I've something to do tomorrow afternoon, so I'll try to start early still. I might start a little bit late, just a little bit. All right, but still connect up a class. If anything else, send a message in the group and let me know. I have something to do near to the class time tomorrow. Hopefully to finish it before class time, but it should be able to. Should be okay. All right, guys, that's it. Very good.
Yes, sir.
Yes, sir.
Yes, sir.
You know the program, go and read the questions, all right? Anything you got wrong, anything you did not do, go and do. All right, guys, see you tomorrow.
Yes, sir.
Bye-bye. All right, cool.
Yes, sir.